We have just marked the switches with namings. Okay, guys, this is a simple circuit diagram of a H bridge which I've made with switches. In actual H bridges, in what to say, motor drivers, they will replace these switches with MOSFETs and IGBTs. Okay, based on the application and loads, these two will vary. MOSFETs can, what to say, handle high loads. IGBTs can handle high voltages, and some differences will come in between them. According to our purposes, we will change these things. Okay, but to demonstrate and to understand it easily, now we are using a manual switches. Uh, this thing won't be efficient when we are using an industrial purpose or other things. For just a demonstration purpose, we are using switches here. Okay, uh, I'll explain what will happen if we press S1 and S4. Just imagine the voltage is coming from here, and it's the electrons are waiting to jump to next terminal. But if until we press this S1, until we press this, the electrons won't flow to the next thing. Okay, once we press this button, the connection will get closed and the electrons will flow here. And imagine the electrons will go till here, and it will go here, and it comes here, and it waits till here. Okay, so it has two option now. After pressing S1, it's waiting to go in some direction. Okay, it will flow accordingly. If you press S4 means it flows via S4. If you press S2 means it flows via S2. But imagine if you are pressing S2. Okay, what will happen is the electrons will go here, and again the electrons will travel here. Okay, always the electrons travels in the easiest path. That means the electrons will travel here, and it goes till here and here. If we press S2 means the electrons will jump here directly. That means the connection is directly going here, and it gets shorted in the sense, not shorted means the connection, what to say, the motor will have no actuation anything. Okay, so imagine now we are not pressing S2, we are pressing S4. That means the connection will go here, and the electron is waiting to go in both directions. Now we are pressing S4. In the sense, the connection will go and inside the motor coil, and after that it flows through S4, and it completes the circuit. That means we have made a complete circuit, and the motor starts to run. Okay, uh, let's assume the motor starts to run clockwise. Wait, let's test it. Okay, S1 and S4, right? Yeah, it's rotating clockwise. Okay, next we are gonna try S3 and S2. S3 and S2. What will happen here? Let's, you guys make a guess. Okay, exactly the thing will happen is the motor will rotate in anti-clockwise direction. Guess why? Because however the circuit completes, but the terminals have been switched. Okay, nothing but the positive is now flowing through motors this direction, and the terminals is being switched. Okay, so now let's press S2 and S3. Okay, and observe the motor. One second. See, motor is rotating anti-clockwise, and if you press S1 and S4, it's rotating clockwise. So simple, it's a simple concept. Okay, the wiring seems here very complex, but nothing to worry, it's a very simple wiring. I'll explain it. The positive, okay, it's coming from the bench power supply. The positive is coming to S1 and S3. See, positive is coming to S1 and S3 is first terminal. Okay, and after that, S1 second terminal, it should be connected to S2 as well as motors terminal. Okay, so instead of making a wire connected to S2 and connecting again to motors terminal, what I have made is I have a connection from S1's second terminal, and observe the orange wire. Okay, I have connected is here. From here I have made a connection to S2's first terminal. Okay, this is the thing. Black one is this, orange one is this. Okay, and here I need to make a connection to motor's terminal. Okay, that's the yellow wire here. See, can you see from yellow it's connected to a motor's terminal. So this is yellow, this is orange, this is black, and this is orange. Okay, so you have no confusion. Same here, I have made the connection simple. Instead of cutting the wire and connecting it back to it, I have connected S3C. It's coming from VCC, and this from the second connection it's going to a common node. From there the motor is getting a terminal, this one. Okay, this one is the white, and from this the red one is here. Okay, and the black is connected to negative of the power supply. So I hope you guys understand this circuit, and let's see what happens if we press S1 and S2 simultaneously and S3 and S4 simultaneously. Yeah, it will get short circuited. Let's see if it happens. Okay, and this technique is used in regenerative braking as well. I think this motor won't be sufficient to perform that experiment, but I'll explain in some other video, or if possible I'll explain later. Okay, the power supply is coming. If we press S3 and S4 or S1 and S2, means what will happen is it will short circuit. Okay, let me press it now. See, the button has been, that means it has been short circuited. Okay, let's power it again, and now let's press S1 and S2. See, it's short circuited. Let's see. Okay, I'm switching S1 and S4 simultaneously. See, the motor is running in clockwise direction. Okay, and for example, okay, what's your guesses if I press S2 and S3 simultaneously? And it's correct, it would rotate in anti-clockwise direction. See, let's test it. See, we press S1 and S4 simultaneously, it's one second, it's rotating clockwise. If I press S2 and S3 simultaneously, it's rotating anti-clockwise. That means this circuit can be used for switching the directions of the motors. Okay, but it's too inconvenient to switch manually. That's why we use MOSFETs and IGBTs. Instead of switching it manually using our mechanical power, we are using MOSFETs and IGBTs to switch the direction of the DC motors. And these things, actually in this H-bridge setup, we cannot control the speed of the motor. Okay, it would be directly controlled by the voltage supplied by us, but we have a method called PWM. Okay, pulse width modulation. In that method, we can also control the direction. We can also control the speed of the motor. So together we will have a motor driver. Okay, it's called a motor driver, which can control the direction as well as the speed of the motors. Okay, this is the advantages. This is the a basic concept of PWM. PWM can be used in many. This is a basic concept of H-bridge. H-bridge can be used in many applications such as power grids and other things, as well as PWM is also used in many applications. The advantage of using PWM is there is no need of increasing or decreasing the supplied voltage, but we can change the intensity in the sense, if we are using a motor, it would change the speed. If you are using a light, it will diminish or brighten accordingly. Okay, PWM is nothing but a constant DC voltage which is supplied in pulses. Okay, I'll explain in next video. So let's wrap it around. I hope you understand this circuit. Okay, for